If you remember a couple of videos back, I bought this Marconi power meter and was a bit disappointed to find that it didn't come with any leads or any sensors where it looked like it possibly did when I bought it in the listing. It was an online auction, government auction site. The meter was in like almost unused condition, really good nick. So I went on the task of trying to track down a lead and a sensor for it. And the worst thing to find are the leads for these. The most expensive part of this whole piece of kit is actually the lead, believe it or not. It's a multi-pole connector made for the Marconi instruments and IFR and Aeroflex. Aeroflex, I think it is. And it's a joint sort of company that obviously took over Marconi back in the I think it was in the 80s or no, it must have been in the 90s actually, because this is a later sort of unit. Anyway, I did a lot of searching and managed to find a lead in Italy, a couple of leads for sale, and put it this way, you have to pay over £100 for just this lead. It's a ridiculous amount of outlay really when you've just bought the meter for like 45-50 quid. You think, well, you're going to get a lead for 20 quid, well, you're not. So it's if you're thinking about buying one of these, make sure that you're prepared to track down a lead, or make sure you can actually get a lead before you actually buy one of these, because there's loads of these for sale on eBay and none of them come with leads unless of course it clearly shows. I think there is actually one on eBay at the moment, actually now, at the time of this video was made, this model meter and a lead and a probe for 330 quid. Well, that's probably close to what I've spent on this thing already. Anyway, we've got two probes here. I bought this one originally. This is a very low power probe. It works from 10 megs to I think 20 gig, is it? Yeah, 10 megs to 20 gig. And it's only got a maximum input power of 20 milliwatt. But that's fine, because that's most of the time that's all you need for calibrating a signal generator or something like that, checking the attenuator and things. These sensors have basically got the connector that mates onto the end of the lead I was just talking about. And there's various different types, but this is an N-type connector terminated into 50 ohms. And also it comes with this chart here that they should supply you with each calibration run. And as you see here, at 10 megahertz there's a calibration of 96.71. So what you do is you connect this up to the lead of the machine, and then connect this N-type connector to the reference power socket here, and then you perform a zero offset first to make sure that all the op amps are sort of like nulled out, so you've got no DC offset, and then you enter 99.97 into the calibration routine, and I'll go through this in a minute, and that sets the reference point for the 50 megahertz output, so it knows that's the calibration of this sensor. There's a couple of other interesting things that you need to set. Linearity factor is 7.6. That's another, basically gives you, I think, the response of the amplitude, you know, for signal, how much. So if you double the signal, you don't sort of double the power. There's an offset, sort of like an offset. It's a non-linear device. These are all basically thermocouples inside these, or these particular probes I have here are thermocouples. So this is the low-powered one. And I bought this for quite a good price. This one came today, and this is bought from Microlease, which is you've probably heard of them. They're a rental company. We've used them before at work, and they rent out equipment for you to use if you don't want an outlay of sort of like a spectrum analyzer or something. You're only going to use it for once. You can rent them from Microlease, and they'll save you having to buy one. This one will work up to nearly 4 watts, and it's also got the ability of running a lower frequency. I don't know if it actually says on here what the frequency is. Yeah, 30 kilohertz. Now, I wanted this one particularly because, the lower frequency signal generators and things like that need a probe that will respond to those frequencies, and you can see the extra heatsink on them. Basically, same thing, N-type connector on the end, 50 ohms, higher powered, and I think that only goes to, is that 4 gig? Yeah, 4.2 gigahertz, which is well beyond anything I'm ever going to use. So that's this probe. So what I'm going to do then, I'll demonstrate how this thing works. I'm doing all this on my phone because I want to try and show you a bit closer up of what I'm actually doing. So So this is our probe. So first of all, I'll connect this up into the power reference socket here, and this has been checked. I've checked this at work on one of their calibrated spectrum analyzers. This power reference is correct. It's producing the right output. There's no point in running a calibration process on this thing if you're not sure of the how good your reference is. Your reference has to be spot on. So first of all, we need to do the DC offset, but before I do that, I just need to turn it round so I can actually see what the settings are on this thing. So the N-type connector is done up correctly there. So we've got a linearity factor of 10. So what we do is we go here and press linearity factor and enter 10. And then we adjust our reference. So this is a 50 megahertz reference. So our 50 megahertz reference is 99.0. So calibration factor 99. Enter. Okay. The first thing I'm going to do is going to do a auto 0. I'm just trying to get you into a position where you can actually see the display. You can see these lines across the display are moving along. It's basically they're the ranges it's selecting. And what it's doing is it's nulling each range. You've got an analog meter on the left here, and that's quite good as a reference, and it's also useful to show you when it's changed its range, as you'll see in a moment when I just once I've completed the offset. So there's our offset adjusted to 0. The next thing to do is to do a calibration run. So at this point you press auto cal. This will turn on the reference and produce the 50 megahertz 1 milliwatt output, and then the unit will calibrate. So it says calibrate here. Takes usually about 30 seconds. Sometimes a bit depends if you change the probe. If you've had this probe on for a while, and you see the meter here on the left hand side, you probably can't see on the display, but it's moving slightly as it's adjusting its gain. Just wait for that to calibrate. Just about finished now. There we go, it's just finished. Okay, so the probe's calibrated now, so it's ready to be used. Now, what you're supposed to do, and it depends how critical you want it, is when you're using different frequencies, you need to keep entering the different calibration or correction level on this probe. But what I'm going to do is I'm going to demonstrate it on the Roden Schwartz. Now, let's get my beer bottle out of the way so you don't see that. Don't really want to see that. Connect this up to the output of the Roden Schwartz's power amplifier. This Roden Schwartz got an additional 1 watt power amplifier in it, and I was actually, one of the things I was interested in was seeing if it was actually producing 1 watt, because I repaired this, I don't know if you recall, about 2 years ago. All the regulator burnt out, so I wanted to check to see if it's okay. So we're outputting 15 megahertz, so unfortunately the generator won't go to 50 megahertz, but let's go to 30 meg. No, we won't. Not on that range, we won't. Okay, 30 meg. Near as damn it. Just have a look at our calibration factor. And our calibration factor at 30 meg is 99.2. Okay, so we're into our calibration factor here of 99.2. Enter. Calibration factor's set. Now I'm going to switch it on to the internal amplifier. So we're running 30 megs into the unit, and presently we're reading milliwatts. It's very difficult to get a good display on this thing with this LCD display, but there we go, 1 watt, and we're not quite at maximum gain, and that ties up pretty well with the vernier on the Roden Schwartz. So let's, you can select different ranges. We've got dBm, which is 30 dBm, which is exactly 1 milliwatt into 50 ohms. Let's wind the attenuator down. I wind the attenuator down, you can see the analog range dropping down, the analog meter dropping down, and then it will jump up to the next range, and it'll come down, and it'll probably do it one more time. There we go, down. and we're out of range of this particular probe because this is quite a high power probe. We're only putting a very low signal into it now. So that works really well, and it's a nice bit of kit and very useful for calibrating all the signal generators. And funny enough, you always assume, well, I certainly assumed that all these generators were going to have pretty accurate output. The Rohn Schwarz was a bit out, but the Marconi was quite a long way out. When I was checking the levels, it was about 7 or 8 dB down, which is quite a lot. So I've managed to calibrate the Rohn Schwarz with the other probe, and got the I'm confident now that the output levels are correct. So it's a really nice bit of kit. Probably not useful for everyone, but the good thing about it is if you've got all the probes and all the leads and it's all working, you're going to get your money's worth. You're going to get your money's worth out of it, and probably get your money back if you sell it sort of 5 or 6 years time. They are, word of caution, they are apparently they say they're quite robust, but it's quite easy to overload them and damage them without noticing. If you look at this power rating here, it says 300 milliwatts for average, and it says 50 watts peak for 2 microseconds. Well, 2 microseconds is, you wouldn't even know you'd done it, would you? So you have to be very careful with them. I have read that they are actually more robust than they sort of let on to be, but you look after them. So these things new were colossally expensive, and I think they're probably sort of old hat now. Anyway, that's a rundown of the Marconi 6960B RF power meter, and thanks for watching.